Okay, so good morning, dear students. I hope you all are good. So first of all, I'm shooting this video on 21st of June, so would like to wish you happy yoga day. I pray for your good health in future. Now in the last lecture, we have started relation and function chapter and we discussed about the relation. There we studied about the certain particular type of relations on a set. Then we go on to the binary relations where we have seen reflexive, symmetric, transitive, then equivalence relation. There we did some questions also. So first of all, let's do some question of relation and then we'll head to the function topic. Okay. So I'm getting one question here. Determine each of the following relations on a set of human beings in a city at a particular time are reflexive, symmetric, and transitive. There is one question, fourth subpart, fourth are x, y, where x and y lives within 2 kilometers. Okay, so there are two people, there are two persons, we can say, where x and y lives within 2 kilometers. Okay, so how we need to just check whether this relation within 2 kilo lives within 2 kilometer is reflexive, symmetric, and transitive or not. Okay, so here x and y. If we talk about reflexive, so we definitely need to take x and x. Okay, where x belongs to our set A. If we are just taking this as A set, okay. For all x belongs to the set A. So x and x, alright. So x and x will be a reflexive one. Why? Because yes, the same person will be living with, that means if I am talking about myself, so I will be me only. That means x and x, we are taking only one element for the reflexive. We always take one element for the reflexive. So x and x, they both will be same only, so hence it is a reflexive one. Then symmetric, it's definitely symmetric because if x and y lives within 2 kilometers, then y and x will also be within 2 kilometers. Okay, so it is definitely a symmetric one. Let's talk about the transitive one. Oh, so, I'm just writing in a very like local way. Not writing properly here, that will take so much time. Okay, so what you have to do, that is why I told you to see the examples there. It will show you how you can represent your solution. Okay, so there please you see, I'm just explaining you the main things. I'm explaining you, the writing work will be yours, totally yours. Transitive, let's see for the transitive one. So for that we need to take three elements, because for reflexive we always take one. For symmetric we need two, but for transitive we need three. Okay, so let's take z. So x, y, and z, we are taking these three elements. So x and y, which means x and y lives within 2 kilometers. Then we need to take y, z, right? X and y, then y and z, they lives within 2 kilometers. Now x and z won't be living within 2 kilometers because x and y, say for example it's x house, this is y house, and this is z house. So within 2 kilometers they are living, and they are living within 2 kilometers. Okay, so can you spot that x and z can have a difference? Like they would be living within 4 kilometers because 2 and 2 will be 4. So that is how we can understand x and z cannot live within 2 kilometer, which is not satisfying the condition of transitivity. Hence we say this is not transitive. So this relation is reflexive, symmetric, but not transitive. Okay, let's go to the next question. Alright, now I'm taking 20th question of the exercise, which can be important question for all of you. We'll see one more question very much similar to this question. But first, let us understand this question very thoroughly. Now, here you are given with, if R1 and R2 are equivalence relation. We know the meaning of equivalence relation. When do we call a class or a relation to be equivalence? When it is satisfying all three: reflexive, symmetric, and transitive on set A. So there is one set A, okay, in which we have two different relations, and they are equivalence relations. Okay, then show that R1 union R2 are reflexive, symmetric, and not transitive. So if we do R1 union R2, then whatever answer we will get, it follows reflexive, symmetric, but not transitive. Okay, so let's understand slowly so that to clear this question. Okay, now this is set A, we are not given with anything. So if such type of questions are there, it is better to take one example and prove it. That will help you, and that will be more clear to the examiner. Okay, so let me consider set A to be you can consider anything like XYZ, ABC, 1 2 3, whatever you like. Okay, so let's take 1 2 3 because that is more better for us. So let us consider. So will you please write here, let us consider A as 1 2 3. Now this set A, let's read the question again. R1 and R2 are equivalence relation on set A. So there is some R1, we don't know that relation. Also there is one R2, we again don't know that relation. Let's make it, let's consider R1. Can we make R1 as one set where it follows all the three, reflexive, transitive, and symmetric? So I'm making 1 2, then 2 1, 1 1, and this one you can consider anything. 2 1, let us consider. Okay, see how this R1 1 2, see first of all 1 1, so reflexive. Okay, 1 2 and 2 1, 1 2 2 1, then 1 1, so here 1 1 is there, so again transitive. So this is reflexive, they both are symmetric, and these all three are transitive. So here we confirm that whatever the set we selected, and from here whatever ordered pair we made, R1 satisfying all the three. Now R2 you can make anything. Do you know this how if we have set A, then we can make the ordered pair of this one. What will be the ordered pair? 1 2 1 1 1 2 1 3, 2 1 2 2 2 3, 3 1 3 2 3 3. So from there I have selected this R1. Okay, so please you can write first of all 1 1 1 2 1 3, then 2 1 2 2 2 3, then 3 1 3 2 and 3 3. Okay, so this will be the ordered pair A cross A, and from their relation I have selected this which is satisfying all three. Now R2 will be what? You can consider anything from this one. Like if I consider 1 2 is already considered, so we need to take this 1 3, then 3 1, then no, let's consider 2 3, this one, because 1 1 and 1 1 1 will be same. Okay, we can take this, no problem. 3 2. Let's consider R2 to be this one. Here also 1 1 is there, that is the reflexive one. 1 3 3 1 symmetric, and this can be the transitive one. Alright, now just see R1 union R2. What will be R1 union R2? Can we make the union of this? Yes. So 1 2 2 1 1 1 2 1. Okay, then 1 3 3 1. This is already we have written here 3 2. Now this is our main question. Now from here let's prove all these three. Okay, reflexive. Is it reflexive? Can you find any repeated? Yes, we got one combination, so hence it is reflexive. Now it is very easy to understand. Like if you go with the proof like A, B, C, X, Y, Z, that may confuse you. Always take digits, always take numbers. This will help you more. Symmetric. Now how this is symmetric? This is already symmetric because 1 2 2 1 and 1 1. So we got this as the symmetric. Even you can give the example of this also, 1 3 3 1 and 1 1 here. So this is the symmetric one. Now for the transitive, it's not a transitive. Why? Let's see here. So for the transitive, we know that 1 2, then 2 1. Is it for the union case? This is for the union case. Okay. So 1 2. Just wait. Yes. So for the transitive, what? See, if I take 1 2, 2 1, 1 1, so I'm having 1 1. But if I take this 2 1, 1 3, okay. So do we have 2 3? Because 2 is related to 1, 1 is related to 3, 2 should also relate to 3. But do we have here in this set, union set? No. So that is how we have to say that for this transitivity, see, for every you have to check that is it a transitive or not for this set. Okay, so 2 1, 2 is related to 1, 1 is related to 3, 2 should be related to 3, but it is not belonging in this set. So that is how we have to say that this is not a transitive case. So that is how it is not a transitive. Now you have one more question. If I replace this R1 with this R2, if I say if this is the union one, now you need to tell me, is it a reflexive, symmetric and transitive, all the three? Okay, so this will be the homework for you. So you have to do this. Okay, now let's come to the next question. Let's see, let's do the 21st one, because this is somewhat different, and one formula you have to remember for this question. Okay, so let's do that. Okay, so we are given with A set with the elements -1 1 3. Okay, we need to find the number of relations on A. Okay, so we need to find the number of relations on A. What is the meaning of this statement? For this we need to use one formula. But before using the formula, first let's see that how many ordered pair we can get. So using the Cartesian product, how many ordered pair we will get here? So you can say -1 -1 -1 1 -1 3. So again 1 -1 1 1 1 3. Then 3 -1 3 1 3 3. So like that 9 ordered pairs. So number of ordered pairs will be how much? 9. Okay. Now the formula says how to find the relation on any set. The formula is 2 to the power the number of ordered pairs, how much you got. Okay, so this is 2 to the power n. So 2 to the power n to 512. So this formula you have to keep in mind for knowing that if this is the A set and if you want to find the relation on A, so this is the formula you need to keep in mind. Okay, rest just try to do. If at all you get any doubt, let me know. I'll make a video of it. Okay, so let's move to the next topic, that is function, which is very important topic. Okay, so dear students, now we are going to talk about the functions. So let me tell you, function, this topic is literally very important for you because many questions are asked from this exercise. So this exercise, next one, so these are somewhat important from the exam point of view. Now let's start the functions. In class 11th, we have somewhat came into touch with this topic functions, where I have taught you many things. So if you are forgetting those that topic, you can go to the 11th class video and there you can understand the meaning of function. But still we'll have some recap here. As I've written here, a special case of a relation. So always remember, a function is a special case of a relation. How? We will see further. But let me tell you, without this function, mathematics cannot be defined. You know, in many of the topics like in 11th and 12th class, without functions, we cannot think of the mathematics, because this has a great impact on mathematics. Without this, we cannot think of calculus, which is the main core part of mathematics. So we need to understand functions very, very thoroughly. All right. So let me just tell you here. So we shall review the concept of function, and in the particular deal with real valued function. This is very important, real valued function. It is there in 11th class, but due to reduced syllabus, we could not cover that topic. No worries, we will see here. Now function of concept of function. You know, there is one diagram made in your book which is very, very nice to explain this. Okay. So this is one diagram. Okay, say for example, here you are giving one input, and under this box there is a machine, and here you are getting the output. So here, how can we define function with the help of this diagram? Whenever you put somewhere here inside, with the help of machine, that particular element or particular thing converts into some other thing, and we get some output. And say for example, we are calling this whole machine or this mechanism as f, then this x is converted by this f, and hence we get the output which is f of x. Okay, so with this diagram or with this mechanism, what can we say? That if we have two non-empty subsets x and y, okay, where x is a function of y, that means we write like this, x is a function of y. Okay, so what we are doing, this is nothing, this is our y, so this is our x and this is our y. So whatever values we are giving into this function, we are getting in terms of f of x. You know, this function can be like sine function. Say for example, I'm giving the value of x as 30. So I'm using this mechanism sine 30 degree. I will get as 1 upon 2. So that is what they are trying to explain. This function can be anything. We have so many types of function in mathematics. Let me just count, like whatever you have seen, trigonometric functions, we will see, but like trigonometric functions are there, logarithmic functions are there, exponential functions are there, signum functions we will study. Okay, and constant function is there. It's written in the book, modulus function is there. So there are so many types of functions. So whatever value we are giving here, under this function we are getting some answer here. All right, you know, you would have seen this f y is equal to fx. What does this denotes? Y is a function of x. So whatever you are giving value here, like say for example, I am giving f of 1, and this fx is say for example x square plus 1. So our function is x square plus 1. If I give x is equal to 1, that means this mechanism is x square plus 1 actually, and I am giving this value as 1, say for example. So whenever 1 is going inside, so this mechanism is working. 1 square plus 1, which is 2, I'm getting final answer is 2. So I got y is equal to 2 when I put x is equal to 1. So see, I'm putting x equal to 1 here, but I'm getting y equal to 2 outside. So inside one function is doing some processing over here. So this is what we are going to study about the functions. Alright. Now in this function, please write the definition from the book. Okay, so alright. Now what is the image of an element? What is the image of an element? Let's see. Here only we can understand. See, by the arrow diagram I am explaining you. Say for example, these are the two non-empty subsets, non-empty set x and y. So whenever I am giving x is equal to 1, I am getting y equal to 2. That means for x equal to 1, I am getting y equal to 2. So here 2 is the image of this element 1. Okay, I am taking one example and trying to explain you what is called the image of an element. So here 2 is called the image of the element. Okay, so you need to remember this. Then we have seen about the domain and range. Okay, what is the domain and range of the function? So this first one, this is the domain and this is the range of the function, or we can say codomain. First of all, you know, I have explained this domain, codomain and range very nicely in 11th IAC relation and functions, so you can go there and watch, so that these things will be clear to you. Okay, I'm not going into this. So domain, codomain and range, there is a difference between codomain and range. Sometimes you can call codomain as range according to the question, whatever thing is given in the question, but always codomain cannot be range, because there can be some difference. Okay, then let's talk about the main features of a function. Okay, let me just rub it. So let's discuss the main features of a function. What are the main features of function? The very first line says, for every x belongs to x, there exists unique y belongs to y. So every element, that means here every element of x, for every unique value of this x, there can have a unique image in y. That means unique image in the range. So are you clear with this? Like for every x belongs to x, there exists unique y belongs to y. So for every x, you must have a unique y here in the range. Okay. Now next one, no element of y can have two images in x. That means it is trying to say that if you have x, y, z, a, b, c. So no element can have two images. That means if I do this mapping, so no element can have two images. You can think of like in practical life, we all say that don't keep two images, don't have the double standards in life. Okay, but though many people have two images, okay, whatever they are in front, they may be in front of us, they may be different in front of any other person. Okay, so but here in the function, no element can have two. This is wrong. Okay, now see, two elements can have a common image, but one element cannot have two images. All right, this I have explained in the 11th video. Okay, now the third one, there can be element of y which may not connected or associated with x. Okay, so like if I'm making one mapping in such a way, so there can be elements of y which may not be connected or associated with. Can you see this C? All right, this is not connected to any of the element of this this set x. So this line is saying that there can be elements of y which may not be connected or associated with x. So that is acceptable thing. Okay, now these are the main features of the this function. Two more features are there. Distinct elements of x may have same sign in y. Like this x, there can be same sign also, maybe there can be different sign also. Okay, so because maybe is written, may have, so generally if there is a positive sign, then here also you'll get positive, or maybe if you are negative, then here also you will get negative. Okay, function f is determined when fx is known for all x belongs to. So to know this fx, we must have the values of x. So to determine the function of x, we must have for all x belongs to x. So that means we need to have some values, then only we can determine the function. Okay, now let us come to the real valued function. Okay, now what is the meaning of real valued function? From the word, can we understand what is the meaning of real valued function? The function which is giving us the real values, right? So that is what this is the sign to show the real numbers. Okay, so whenever a function which is giving us the real values, like say for example, again the mechanism, I want to just make the diagram over here, that here you are giving some values. Okay, real values. So here also you must get a real value. Okay, so x and y, so they must be a real, so how to get the real value? If or you can say, if you are giving some input here and you are getting output as a real number, okay, so giving real number in the input, getting real number in the output, so the mechanism which helped it to make a real value, already we are giving the real value, so the mechanism which helped it to make a real value, so that is what the real valued function they have defined. Okay, so from the book, please see the definition of this, okay, and please write the definition in the copy, okay, and then let's come to the domain and range of a real function. Okay, this we will see in the question. We'll do questions of this exercise to just have some understanding of all these topics. All right, if you have not understood all these topics, no worries. Okay, by doing the examples, by doing the questions, you will get to know some concept of this, all these things. Okay, so let's do some questions now. All right. So, dear students, before starting the questions, I just want to make this thing clear that what are the following important points which should be kept in mind when finding the domain and range. Okay, because this is very important. What is the clear cut way, because many students get confused in these questions. So let me first clear this thing. In this exercise we will be dealing in the real valued functions. Okay, so where real numbers are very much important for us. Okay, so let me just give you some important points of it. First one, like say for example, if you have a function, a quotient function, if you have such type of function, that is a rational function, sorry, you know the meaning of rational function, the numbers which can be expressed in x by y form, those are the rational. So this is a rational function where I'm taking some numerator, some function of x, and some function of f and some function of g, the two different functions. So here what does this say? Your gx should not be equal to 0. Okay, so whenever you want to find the domain and range of this particular thing, your denominator should not be equal to 0, because if it does, then your whole thing will be infinite, not defined, and there you cannot find its domain and range. So say for example, I am taking one question, like if we have fx is equal to x plus 1 upon x minus 1. Okay, so here what you have to do, you take this denominator equal to 0 and check what you are getting the value. You are getting x equal to 1. So leaving 1, all the full real numbers will be your domain, and the range I will explain you. But here just try to understand what I am trying to say. This denominator should not be equal to 0. So here x should not be equal to 1. Okay, in this whole, if you want to find the domain and range of this, okay, x should not be, in the 10th class in quadratic equation chapters or in linear equation, sometimes you would have seen the question, and at last they used to write x should not be equal to minus 3 and 2. So this is what they are saying, that this will give you a not defined result, an infinite result. That is why excluding these values you have to see. So this is the very first point you need to remember, that your denominator should not be equal to 0, because this will give you an infinite result. Okay, or we can say a not defined result. Then what else? In under root, minus term should not be there. That means like say for example minus 1. So this should not be there. How? Let's see. Like under root of x minus 2. Here I'm taking x minus 2. So what I need to do, I need to take this values of x equal to 2 or more than 2. I cannot take less than 2. Like I cannot take 1, because under root of 1 minus 2 will give you under root of minus 1, which will go in complex numbers. Okay, which is not real. okay, because that is a complex, that is imaginary term, that is not real. So here I told you that we need to deal in the real valued function, so that is why here x cannot be 1, it will be more than 2. So that is how we will be going to find the domain. All right, did you understand this? So these 2 points you keep in mind. Or one more thing, like whenever you get some condition where you are getting infinite as an answer, so we need to ignore that thing. So here 2 things, these 2 points you need to keep in mind, and we have to do the question. Okay, so as I think we don't have that much time. All right, so I'm ending up this video. So this important points you need to remember. In the next lecture we will take the questions of this exercise, and if possible we'll go to the types of function if we get time. All right, so please keep in mind this thing, and if you want you can see the examples and start doing the exercise of it. Okay, so till that, thank you so much, have a nice day.